So, what is the deal with gyroscopes? Well, the point we're trying to make here, or prove here, the point we're trying to prove here is that a gyroscope has a principle called rigidity in space. And what that means is it means it defies gravity, and whatever angle you set it, it'll stay at that angle. And that's why they put these instruments into jet fighters and into planes that twirl and spin, because that artificial horizon that actually has a gyroscope inside of it will always be horizontal, because a gyroscope has a rigidity in space, which means if you start a gyroscope spinning in one angle and the earth turns, well, then you should see that movement, because that gyroscope should maintain its angle at all times. And that's the point we're trying to make. So I modeled this 3D Earth with this gyroscope on it. I want you to notice the rigidity in space. So it's always facing you. This is if you're in space. It'll always face you. It has a fixed point of reference in space. So if you were out in space, this is what you would see of that spinning gyroscope. Next, I will show you how an observer on Earth will see this exactly same animation if he was on Earth. Here it is. See, you can actually see it moving. And depending on what angle you were holding it at, it would move in a different direction. And this is the point I'm trying to make. I've put cable on the sides and I've taken it down and it's plugged into the wall there. But the problem with this is that just the slight tension of those electrical wires, although I've tried to make them not make any tension whatsoever, is enough to readjust the gyro, which I'll show you. So goes there, keeps the horizontal position, but the weight of those wires push the gyro back. The weight of that coil, see? Push it up, and readjusts. We're going to have to go back to batteries and come up with another plan. We have to time the batteries, see how long they last for, because the whole point behind a gyroscope is precision, and it has to be balanced perfectly. So this cable story isn't going to work. If you guys have any other ideas how we can make this work, then give us a shout. You know, I spoke to my son and I told him the problem that I had with the gyroscope, with the batteries running flat, and that I still published it. And he said, well, Dad, why did you publish it? And I said, well, because I want the people to come along the journey with me, and I want to broadcast everything, whether it's a success or whether it's a failure. You see, I know God's word is true, so if I've misinterpreted it, then I will tell you guys, look, you know, hey, the earth's round. But if I'm not honest and upfront with you to start off with, you know, how on earth are you going to believe me? So this is why I'm going to publish everything, guys, and we're going to just look at the facts, because I really believe and I trust that God's word is true. Yeah, so I think the best we can do now is just to go back to batteries, see how long the batteries last, and then work out what angle it should be at if the earth really is rotating. I'm sure we can work out some formula. I know it's 24 hours for the planet to rotate, so if it were to rotate quarter of the way would be 6 hours. 24 divided by 4. Yeah, so back to the drawing board.